Exoplanets or extrasolar planets are planets that orbit stars outside of our own solar system. Trying to locate exoplanets in interstellar space is a very challenging and daunting task. Planets emit minimal or no light, while their host stars shine brilliantly, which makes it even more difficult to locate them. In the early 1990s, the first exoplanets were discovered. However, it was the detection of exoplanet 51 Pegasi b, also called Hot Jupiter, truly captured the world's attention. This marked a significant turning point as it opened the door to the discovery of thousands more exoplanets. Today, we are continually gaining knowledge about these distant worlds. There are currently over 5,000 known exoplanets, and this number is growing rapidly as new discoveries are made. Different methods are used to detect these exoplanets. Methods like transit method, radial velocity method, gravitational microlensing, astrometry, and direct imaging are the most widely used. The transit method is the most utilized approach to detect exoplanets. In fact, this method accounts for more than 70% of all detected exoplanets. Exoplanets are not directly visible from many light-years away, but rather discovered through transits. As planets pass in front of their stars, they cause a slight dip in the star's brightness that can be observed through light curves. Transit is an effective tool for identifying the exoplanet characteristics like size, orbit, and atmosphere. As planet transits, light passes through its atmosphere, can then be examined to deduce the elements present in its atmosphere. During NASA's Kepler mission, which ran from 2009 to 2013, the transit method was employed to locate new exoplanets. Thousands of potential discoveries were found through this process, providing valuable insight to astronomers regarding the distribution of exoplanets in the galaxy. The radial velocity method is a technique that detects exoplanets by observing the subtle changes in a star's movement that are caused by the gravitational pull of an orbiting planet. The planet's gravity causes the star to slightly wobble around, with the effect varying in strength depending on the exoplanet's size. Using the Doppler shift method, scientists measure the wobbling stars and track the changes in light waves that occur as the planet moves to and fro. This causes the light waves to compress and stretch out, changing the color of the light we see. The radial velocity method was one of the first successful ways to find exoplanets, and continues to be one of the most productive methods. Over 1,000 exoplanets are found using this method. Direct imaging is an emerging exoplanet finding technique that shows potential in discovering and studying exoplanets. As technology advances, capturing images of exoplanets could soon be possible, allowing the identification of atmospheric patterns, oceans, and land masses. Taking pictures of exoplanets is difficult due to their distance and the brightness of the stars they orbit. The stars are millions of times brighter than the planets, making it hard to capture any light reflecting off the planet or its heat radiation. However, new techniques and advancing technology are making it possible. Instruments designed to directly image exoplanets use techniques to block out the light of stars, so that objects around them can be better observed, like using sunglasses or a sun visor to block out the sun's glare. Astronomers have two primary techniques for obstructing starlight: first, coronagraphy, which is an internal device within a telescope. And second, the usage of a star shade, a separate spacecraft created to block light from a star before it enters the telescope. The latter is commonly used when searching for exoplanets using a space-based telescope. Gravity can warp light, creating a lensing effect known as gravitational microlensing. This means that a star or planet's gravity can magnify the light of a distant star, making it appear brighter. As light rays travel from a distant star, they can be bent around an exoplanet or star and reach an observer. This causes the brightness of the distant star to fluctuate and can be charted in a graph, showing an increase in brightness during lensing by the planet and star, followed by a decrease, as the gravitational lensing is used by astronomers to detect distant stars and planets, which appear as a brightening and dimming of a star over time. Lensing star moves out of the optimal position. This unpredictable process requires extensive observation to capture and analyze, providing insight into the size of the star and even free-floating planets in space. The latter can help astronomers estimate the frequency of rogue planets in the galaxy. Aside from the well-known Doppler shift method, astronomers also use astrometry, which involves monitoring the star's apparent position in the sky. This method is quite challenging and requires precise optics, as stars wobble such a minute distance that detecting their movement from planets, especially small ones like Earth, is a daunting task. To track the movement of these stars, scientists take a series of images of a star and some of the other stars that are near it in the sky. They then compare the distances between these reference stars and the star they're checking for exoplanets. If the target star has moved in relation to the other stars, astronomers can analyze that movement for signs of exoplanets. However, astrometry is even more difficult from Earth's surface due to atmospheric distortion and light bending. The discovery of exoplanets has raised the prospect of the existence of life beyond our planet. Scientists are exploring these planets for specific signs, such as water and organic molecules, to determine the presence of life. The discovery of extraterrestrial life would be an extraordinary event that would transform our understanding of the universe and our place in it. The study of exoplanets is a rapidly expanding field of astronomy that is continually uncovering new findings. Our knowledge of the galaxy's diverse collection of planets is constantly growing. The search for extraterrestrial life remains one of the most exciting and challenging frontiers in science today.